So question says, 5 new high-definition television models are compared. The distance in miles over which a clear signal is received and a random trials for each of the models is summarized in the table below. Do you believe there's a difference among the 5 models? So the distance is quantitative, type is categorical with 5 categories. So since we have a quantitative variable and a categorical variable with more than 2 categories, we need to do an ANOVA, so an analysis of variance. So it wants to know what are the appropriate hypotheses. For an ANOVA, we're just always going to assume that the 5 means are the same. Not necessarily that they're 0, just that they're all the same. So that eliminates A and B, because the null hypothesis for C and D says the 5 are all the same. An alternative hypothesis is going to say at least one of them is different. Not all of them are different. So D says all 5 of the means have to be different. We just want to know, is at least one of the televisions separate from the rest of them? So that's what C says. So this statement is wrong, making it the correct answer C. 9 says we want to know what are the degrees of freedom for the test. So when we're doing an ANOVA, we have 2 degrees of freedom. We have our numerator degree of freedom. That's going to be the number of categories that we have. So we have 5 televisions. We're going to lose 1. So our numerator degrees of freedom are going to be 4. And our denominator degrees of freedom is going to be our total degrees of freedom minus the degrees of freedom we have in our original. So it's going to be 74 minus 4, which is 70. So the correct answer is E. 9 says, what are the degrees of freedom for the 10 says, what are the value of the test statistic? So what we're going to do is we want to find MS of the treatment, so the difference between the televisions, and we want to divide by MS of the error. How much do the televisions vary from within each category? So MST is going to be the sums of squares of the treatment divided by our degrees of freedom. And then MSE is going to be the sums of square error divided by their degrees of freedom. So that's going to be 537 divided by 4. I'm going to take that whole thing and divide by 221 divided by 70. And that's going to equal 4.65. And then from there, we want to find what the p-value is. So this is what we call our F test statistic, because it's going to follow an F distribution. An F distribution is a right-skewed distribution, so we're going to draw a right-skewed distribution. We want to mark where our test statistic falls at 4.65, and then an F test is always going to be a right tail test. If the distribution is skewed, we only have a right tail test. We can't do two tail or a left tail. We always want the upper area. So this is going to be F CDF. Our lower bound is 4.65. Upper bound some large positive number. Our first degree of freedom is our numerator, just 4, and our second is our denominator, 70, and that's going to give us 0.002. So how we do it on our calculator is we find FCDF in the same place we find all our other ones. We just want to scroll down until we see FCDF 4.65, some large positive number, 4 for our numerator, 70 for our denominator, and we get 0.0022.